Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Welcome to Lady Khadija Radiallahu Anha Online College. Today we are doing A-level maths at a section in the mechanics module, and it's Projectiles chapter 6. And the aim is to do the whole chapter in just one session from 1:30 p.m. now to about 5 o'clock, inshallah. We'll take breaks in between. But let's see how we do. Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Let me introduce you to a little bit of artwork and then some formulas. So let's imagine we have a little truck going across the screen, hopefully with the same size wheels. And this little truck is going to start going across the screen. And oh, we don't want it to show red behind. It's going to go across the screen and then stop. So in that little movement, there's a couple of things that you want to try and note down and understand. We're going to be using them a lot in the chapter. The first thing is the initial velocity. So that's the speed that the truck started off at. Literally, it started off at 0. So we would say the initial velocity was 0. And the letter we use for initial velocity is u. So in this case, u was 0, but in other questions, it might be more than 0. So u is initial velocity. That's the speed that it had right at the beginning. Then as it went across the screen, now it's got a different velocity. And when it stops, that's the final velocity. Sorry, not when it stops, but when it gets to the end of the screen, that's the final velocity. And in a typical question, the thing might stop or it might just pass a finish line. So it hasn't necessarily stopped, but when the speed that it passes the finish line at, that's called the final velocity. And the letter we use is v. Then we can look at, well, if it started here and it ended here, then the distance in between, that's interesting as well. How much distance did it cover? And that's also known as displacement. But you can just think of it as distance, really. But the proper word is displacement, and we use the letter S for displacement. Then comes how much time did it take, and we're going to use the letter T for time, typically measured in seconds. And then the other thing is sometimes a vehicle will go faster and faster and faster. That's known as acceleration. So we're interested in also knowing about the acceleration. Okay. Today, all the questions are going to assume that the truck is just going happily across the road or along the road, and there's no friction, there's nothing slowing it down, there's no air resistance. It's very, very simple, very easy for the truck to go forwards and backwards. When we come to objects falling, then also we are going to have to take into account something else. So if you imagine there's a ball and it gets thrown, then the speed that it gets thrown at, that's called the initial velocity. And if it's falling, if somebody just lets go, then it's accelerating down to the earth. That's because of gravity. So typically the acceleration for any object downwards is always going to be equal to gravity, the acceleration of gravity. And that's 9.8 meters per squared. 9.8 meters per second squared. That's a very important number for you to remember, and that won't be given in the exam. You have to remember that. Okay, good. So let's give you a couple of formulas that we can put all those letters together. The first one you have to try to memorize is that final velocity is equal to initial velocity plus acceleration times time. That means that if you've got a truck going along at that started its journey at 10 meters per second and accelerated 1 meter per second squared, and it went along for 4 seconds, then you just put those numbers into the equation and then it'll tell you what the final velocity was of the truck. Next one is to do with velocity again, but this time the formula starts off with velocity squared. So the velocity squared, this is a good formula because it avoids time. Sometimes you don't know how much time has been taken by the object. So velocity squared is equal to initial velocity squared minus 2as. And then a third formula, s is s. So remember, s is the displacement or the distance traveled. And that's equal to, in this formula, ut, initial velocity times time, plus a half at squared. A half at squared. I've written half as a decimal, but in the original formula, it's written as a fraction. There are a couple of other formulas, but I normally find that you can get away with most questions just by using these formulas, and that'll be sufficient. But just in case, just so that you don't get surprised if you ever see them, another formula that we could use for distance or displacement is bracket u plus v over 2 times by time. And then there is another formula again for distance. S is equal to vt minus a half at squared. But really, it's the first three formulas that you want to concentrate on. So I'm just going to give you a minute to try to memorize these because you will need them again and again through this chapter. And while you're memorizing it, I'm just going to take that zero point 0.5 and replace it with the fraction a half. Okay, let me give you a minute to memorize those formulas. Okay, so let's begin with our first scenario of projecting a particle. So first thing you have to imagine in this question is that there's a cliff edge, and you can imagine the sea at the bottom, and the height of the cliff is 78.4 meters. 78.4 meters. And we're just going to replace the sea with the ground, just so that we can do a couple of questions later on when the particle hits the ground. So particle just means some kind of ball, but the reason that we say particle is because we don't have to worry about the size of the ball. So it's really a ball, but in the question that you'll be faced, it's just called a particle. So it's projected, meaning thrown from the edge at a horizontal velocity of 25 meters per second. Notice that's the horizontal velocity. So it's projected horizontally, meaning it's thrown horizontally at an initial velocity of 25 meters per second. Let's draw that in using a vector. So it's projected horizontally at a speed of 25 meters per second. And the question is, calculate the time taken to reach the surface. So imagine this ball falling and then eventually hitting the surface. Well, how long is that going to take? So let's see what we know at the moment. Let's jot that down nice and clearly. We know u is equal, the initial velocity is equal to 25 meters per second. Notice that that's horizontally. We also know that you also have to think vertically as well. So vertically, the particle doesn't have any speed at all at the beginning. So we can say u vertically is equal to 0. It's important in these questions to get an idea in your head that you have to look at them in two ways, vertically and horizontally. Okay, what else do we know? We know that the acceleration going down is going to be due to gravity. So vertically, the acceleration is going to be due to gravity, and that's 9.8 meters per second squared. We know vertically the distance is 78.4. So let's write that down as well. We don't know the time. The time is what we're trying to find out. We don't know the velocity when it hits the ground. We don't know that vertically for sure. But we do know it horizontally because nothing is going to slow it down horizontally. We're assuming no air resistance, no friction. That applies mainly in the whole of your A level for these kind of questions. You don't take into account any air resistance or friction against the particle, so we can say that there's nothing slowing it down, so its final velocity will also be the same as its initial velocity. So we've looked at horizontally and we've looked at vertically, and the whole question is, can we work out the time that it's going to take to hit the ground? And the answer is yes, because we've got so many numbers here. U is known, acceleration is known, distance is known. It's only time that's not known and velocity that's not known. So with so many numbers that we know, the question is really, can you pick the right formula that will tell you what t is? So let's just take a look at the couple of formulas we learned and try to think, is it going to help us? So the first formula I put on the screen was v equals u plus at. V, if we're looking at it vertically, because most of the numbers we have are vertically, v we don't know, u we do know, a we do know, but t we don't know. So the problem here is that there'll be only two numbers we know and two numbers we don't know. We can handle one number we don't know, but more than that is going to be a problem. Let's take a look at another one. S equals ut plus half at squared. That's the another formula that I'd written down. Is this going to help us? Okay, let's take a look. Vertically is again the best option. So let's put the horizontal data to the side and let's just talk about vertically. S is known. The u we know is 0. The t we don't know. That's fine. We're allowed to not know one number. 0.5 is just fine, is a constant. That's fine. The acceleration we know, it's 9.8. And the t is not known, but it's the same t that's not known here. So that's fine. We only really have one number that we don't know. All the rest we do know. So let's use that formula. Let's plug everything in. Let's substitute everything into that. So let's see what we get. First goes in 78.4, and that's equal to u is 0, so 0 times t is just going to be 0, so that just cancels out. 0.5 times a we know is 9.8, and t squared will just leave as t squared because that's not known. Okay, that's looking pretty good. From there, we're just gonna rearrange and solve. So I can take the 0.5 times 0.8 to the other side, as a divide, and then I can square root that to figure out what t is. Remember, you'll get two, when you square root, there's always two answers, a positive and a negative. In mechanics, it doesn't, sometimes we can take out the negative answer straight away because you can't get things like negative distance or negative velocity, negative speed. But sometimes we'll have to keep it. So let's plug this into a calculator. Let's also draw in the square root as well. So to get rid of the t squared, I'm going to have to square root everything. So that means the square can be crossed out. Okay, let's grab a calculator. Okay, 78.4 divided by 0.5 times 9.8 and square root that, and you get 4, which is fantastic. So we now have figured out how long it takes to hit the ground. That is a time of 4 seconds. Notice that if it's going to take 4 seconds to hit the ground, then that's still 4 seconds whether we look at it horizontally or vertically. Time is time. You don't really look at time horizontally or vertically. It's the same thing. So we can say time is 4 in whichever way you look at it. Fantastic. Okay, the next part of this question is to figure out the distance, the horizontal distance traveled in that time. So if you imagine it's going to hit the ground maybe about here, and what we want to know is what's the horizontal distance? How much distance has it covered horizontally? Because the question says horizontal distance, then we have to look at all the numbers that we know horizontally. So let's make a bit of space and take a look at that. So vertically, we can put those numbers to the side. That's probably not going to help right now, but let's look at it horizontally. So what do we know and what do we not know? So we know u is equal to, the initial velocity is equal to 25 horizontally. We also know the final velocity is equal to 25. We know that the time is equal to 4. We want to know what the horizontal distance is. Acceleration, we know it's 0 because we're assuming in these kind of questions that nothing's going to slow it down, no air resistance, no friction. So actually we know everything except the distance. So let's put that into a formula. There's only one that starts with s that I told you earlier, so let's try that one first. S equals ut plus half at squared. And let's just check that we have enough to put into that. So starting on the left, do we know what s is? No, we don't. That's fine. We're allowed to have one unknown. So let's put a question mark there. That's your unknown. U, the initial velocity, we do know. It's 25. Time we know is 4. 0.5 is fine. Acceleration is 0. And the time again is 4. So we know actually everything. So let's substitute that in. Gonna need it to just make a bit of space here. While I'm doing that, see if you can try it yourself, see if you can substitute in. There's no rearranging needed, so it should be quite a quick one for you to do. So let's put it in, put the numbers in. S is unknown, so we can leave that as S. U is 25, time is 4, so that's 25 times 4, plus 0.5 acceleration is 0, which will make the whole thing 0. So I can just cancel all of that. That's s is equal to 25 times 4, which is 100. So the distance it's traveled is 100 meters. Okay, moving on to the next example. This time we don't have a cliff, but we've got a kind of horizontal platform and we're just projecting the particle from the end of it. And what are we told? We are told that the horizontal velocity at the beginning is 15 meters per second. And the question is, can we work out the horizontal and vertical displacement? That means the distance horizontally and the distance vertically. So that's two separate questions after 3 seconds. After 3 seconds. So let's try horizontally first. Let's look at things horizontally. What do we know? We know that the initial initial velocity is 15. We know the acceleration horizontally doesn't change, is 0, so the speed isn't changing. We know the final velocity is also going to be 15. We know that time is equal to 3, and it's s that we're trying to find out. So let's grab the formula for s. S is equal to ut plus half at squared. Okay, s we don't know. The u is 15. The time is 3. The acceleration is 0, which will make this whole thing 0. So let's plug that in and we will get s is equal to 15 times 3. And that works out to be 45. Fantastic. So we know the horizontal displacement. The horizontal displacement is 45 meters. Let's try to do a similar thing vertically. So now we're looking vertically. What do we know vertically and what do we not know? So vertically, when it's fired off, remember it's fired off horizontally. So vertically, its initial speed velocity is 0. There's no push down or push up or throwing down. So initial speed vertically is 0. The acceleration it's going to experience is equal to gravity. So that's 9.8 going down. The velocity, the final velocity after 3 seconds, we don't know. The time we do know, that's 3 seconds, and it's s we're trying to find out. So let's think of a formula where preferably we don't have to use v because that's not something we know. So we've got u, a, and t as knowns, s is unknown. So we can try the same formula that we did before. S equals ut plus half t, a squared. Sorry, s equals ut plus half at squared. Okay, and you should be confident now. You've seen it a couple of times. Just substitute in. So in this case, we've got u is 0 times time of 3. So because u is 0, that makes that whole thing 0, plus 0.5 times the acceleration of 9.8 times time squared. Time is 3, and so I need to do 3 squared. Just simple substitution, and then just take a calculator and simply type it in. So it's 0.5 times 9.8 times 3 squared, which I know is 9. So I'm just going to type in 9, and that makes 44.1. So I now know the vertical displacement is 44.1. just going to make that a little bit easier to see. Okay, and then the next part is, can you work out the distance of the particle from where the point where it was fired off? Now you're probably thinking, hold on, that's what we've already worked out. We've worked out the horizontal distance and the vertical distance. The new thing you want to learn here is that displacement is used horizontally and vertically. So it's more like coordinates, that we know the particle's gone 45 this way and then 44.1 this way. And then distance is the actual straight line distance from the beginning to the end. So that's what we want to draw out and, and then work out that. So let's try using a different color. So horizontal displacement we know is 45. So that just means a straight line across of 45 meters. And then I know that the vertical displacement is 44.1. So I can draw that down here, or it's normally easier just to carry on from where I left off. So vertical displacement of 44.1 can be drawn like that. And then the distance means the straight line distance from the beginning to the end. So that would be this brown line from here. That's what we're trying to work out, this distance here. And Pythagoras will do it because this is a right angle triangle. So we're going to use a squared plus b squared is equal to c squared. You can probably do this quicker than me, but have a go. Have a go if you can. But I'm going to use 45 as my a. So 45 squared plus 44.1 squared is equal to c squared. Type that into a calculator. So 45 into scientific calculator. So you've got 45 squared plus 44.1 squared. That's 3969.81. And then we just want to square root that. And you get 63.00. So we can say that the distance traveled, not just horizontally, not just vertically, but overall is 63.00. That just rounds to 63 meters. Okay, hopefully you're finding it comfortable so far. Let's take a look at the last example of this section. So in this question, we've got a particle again being projected horizontally. We know that there's some kind of cliff or platform. So let's draw that up here. So in this question, this is where the particle is being projected off. We've got a distance here of 122.5 meters. The initial velocity, and this is what makes this question different to the rest, is that the initial velocity, it's going horizontally, but we just don't know it. So all we're told is that it's u, so it's unknown. And what we are told is that when the particle eventually hits the ground, then it hits the ground 90 meters away from the starting point. And the question is, can we find the initial speed of the particle? Can we find that u? So let's take a look horizontally first and see what we know and what we don't know. Probably we're going to end up needing to go vertically, but let's just take a look horizontally. Horizontally, the initial speed is unknown, so we're just going to say it's u. Acceleration, there is no acceleration horizontally. That means that v is unchanged. Time is unknown, but we do know that s, yeah, the horizontal distance, we know that that's 90. So actually, we might have enough if all we wanted to work out was something like time, perhaps. But at the moment, we're trying to work out u, and there's not quite enough there to be able to work out u, especially with time unknown. Okay, let's take a look vertically, see if we might be able to plug in at least one more number to be able to work out something. So let's take a look vertically. So vertically, because it's starting here and it's not being thrown down or pushed down, then we'd say the initial velocity is 0, which is a good start, because at least that's a number we know. We'd say that the acceleration is due to gravity, so that's 9.8. We know the distance traveled is 122.5, because it hits the bottom. And time is unknown. And the final velocity is unknown. Okay, so maybe there is enough to be able to work out time here, which we could then use in the horizontal section and be able to work out something more here. So let's see if we can work out time. We need a formula that's got UAS and time in, and that's the one that we haven't used yet. So if you remember from the beginning, I wrote down v squared is equal to, oh no, we have used this quite a lot, so it's okay. V equals u plus at. So the problem here is we don't know what v is and we don't know what t is. So we're not going to be able to use that formula. Okay, the next one we could go for is s equals ut plus half at squared. So here, do we know s? Yes, we do. It's 122.5. We know the u is 0. Time we don't know though. That's the problem. We don't know what time is. That's okay. We can have one unknown. And then zero point 0.5 is fine. The acceleration is fine as well. That's 9.8. And then time is unknown. But again, that's okay. We're allowed to have one unknown. So let's use that. We've used it a couple of times already, so you should be confident. So let's put the numbers in. For S, 122.5. The U is 0, so 0t is just going to be 0. Then comes the zero point 0.5. A is 9.8. Acceleration is 9.8. And then t is unknown, so I'm just going to write that as t squared. Okay, let's rearrange and work out what t is. So first thing I'm going to do is just move this over as a divide. And that means I can just type it in and then square root it, and that'll give me t. Okay, let's try that. 122.5 divided by 0.5 times 9.8 gives me 25. Square root that, which you won't need a calculator to do, but let's do it anyway. So that gives me 5 for time, which is fantastic because time can be used up here. So I can now say the time is equal to 5 seconds. And now let's try to work out what the initial speed is using acceleration is 0, s, the distance is 90, and time is 5. Think through your formulas. Which formula is going to help us? Okay, I'm going to go for v is equal to u plus at. Unfortunately, yeah, will that work? Let's see. V is unknown, u is unknown, but actually they're the same. So I can just change that v because it's the same. Nothing happens horizontally to the speed. It doesn't slow down, it doesn't speed up. So actually I could use u for both. Acceleration I know is 0, t is 5, but that's just going to end up with u is equal to u. That's not going to tell me anything. Let's try a different formula. So let's go with s equals ut plus half at squared. I'm trying to work out what u is. That's my whole thing. Can I work out what u is? So s is 90, I know that. U is unknown, so I can have one unknown. Time is fine, time is 5. Acceleration is 0, and then the time again I know. So that looks like it's going to work because there's only one unknown. So let's put the numbers in. Starting with s, 90 is equal to, the u is unknown, let's leave that as u, and the t is 5, so that will make 5u. And then solve that, and you get u is equal to 90 divided by 5, which is equal to 18. And that's your answer for the initial velocity. Okay, I'll just go over the last part of that just in case you weren't quite clear. When we looked at all the numbers we had horizontally and vertically, we figured out that we had more of a chance of getting an answer by looking at things vertically because there were more numbers that we knew. So if we can just figure out what time is, then we'd be able to use that same time number horizontally. So we focused on vertically first. We chose a formula that had at least most of the numbers that we could substitute in. The v equals u plus at wouldn't help. S equals ut plus half at squared, that was okay. What only the time was unknown, so we substituted in, worked out what time was, and then having known what time was, we could apply that in the horizontal motion and say, look, we know what time is, we know acceleration is 0, we know the displacement is 90. Let's find a formula to put everything in. So we chose s equals ut plus half at squared because we're trying to find out what u is. So the formula's got to have u in it. It's okay for u to be unknown, but everything else we do know, and that worked out to be u equals 18. Okay, let's time for you to practice now. You've got to get practicing before you become good. Watch as many videos as you want, but none of them will make you good enough to sit an exam until you do the practice questions. So let's grab some practice questions for you. just taking a little bit of time to load, so just give me a minute. Pop up. Okay, these are 2 questions for you to attempt. See how you get on. I'll allow up to about 10 minutes for you to have a go at that. Bismillahirrahmanirrahim. In the name of God, the most gracious, the most merciful. That should hopefully be enough time for you to answer those questions. Let me give you one more minute before I take answers. Okay, a two-part question and then one other question. So hopefully you've got at least one of those questions done and the second one attempted. But let's see what answers you've got. If you can just type in your answers now. So question 1a, type in the value you got for h. And then question 1b, horizontal distance covered. And then question 3, just the answers there. Let's take a look. Okay, still waiting for the right answer on this. Okay, if you can print screen those questions, or if you've got the book, then it's page 110. It looks like you need a lot more practice on the basics, so try to get that done as soon as possible. Bismillah ar-Rahman ar-Rahim. Let's continue, and we've got now the particle is being fired off at an angle. So let's just remind ourselves how we resolve vectors or resolve forces. We've done it a couple of times now in the previous chapters, so hopefully you're comfortable with this. But if you imagine there's a vector or a force and being and it's not straight up, it's not straight down, but it's at an angle, then we can split that force or split that vector into a horizontal part and a vertical part. So that's called component. So there's the force, there's the vector. The horizontal component would be up to about here, and then the vertical component would be about this much. Let's put some numbers on it. Let's say the original vector was 10. Then if we want to work out the horizontal or the vertical component, you just have to look at the angle and say, look, is it adjacent to the vector? If it is adjacent to the vector, so here's we're looking at the horizontal component. The horizontal component is right next to the angle, so that is adjacent. Then we're going to use cos. We're going to use 10 times cos 30. And when let's take a look at the vertical component, that's not next to the angle of 30. It's not adjacent, so we can't use cos. Instead, we have to use sine. So this component will be 10 times sine 30. So you try another one. Let's say we have a velocity, a particle is being fired off at a velocity of, let's say, 20 meters per second. But that 20 meters per second is an angle. And let's say the angle is to the vertical. Can you work out let's say the angle there is 35 degrees. Can you work out the vertical component and the horizontal component of that 20 meter per second velocity? Okay, hopefully you've got that. So let's draw it in first. The vertical And the horizontal components, you've got the vertical component going up here, and then you've got the horizontal component going up here. Let's take a look at the horizontal component first. It's not next to the angle, it's not adjacent, so I can't use cos. So this one will be 20 sine 35, and this one is next to the angle, so 20 cos 35. Okay, good. Let's go straight into the first example of this section where we've got a particle being projected at an angle now. So let's draw in the particle. And what we're saying now is that it's being fired off at an angle. The initial velocity is 40 meters per second, but you can see here that's not 40 meters per second straight up or straight across, it's at an angle. What is that angle? The angle, we are told the angle, but you just have to do a little bit of work to get it. Just a little bit of work, not too much. So we're told that the angle is alpha such that tan alpha is equal to 3 over 4. So that looks like we don't know what alpha is, but no, we do, because you know how to inverse, and you also know a little bit about sine, cos, and tan. So that's enough to be able to work out what the angle is. So that's as good as knowing what the angle is. The question is, if this particle is fired off at an velocity of 40 meters per second, then what is the horizontal component of the velocity? Question is, work out the horizontal component of the velocity and the vertical component of the velocity, and then express it as a vector. So let's do that one at a time. So the horizontal velocity is going to be along here. So that is right next to the angle. That's adjacent to the angle. So that's going to be, I'm going to use cos for that. So that's going to be 40 cos alpha. And then the vertical velocity is going to be up here. That's not next to the angle, so I'm going to use sine for that. So that's going to be 40 sine alpha. So let's work those out as a number because alpha is known. So the first thing we're going to do is grab a calculator and we're going to inverse tan 3/4. So 3 divided by 4, and then you can inverse tan that. So you get that's your angle alpha. And then we're going to do, to get the horizontal component, we're going to do cos of that, which gives you 0.8, and then times that by 40, which gives you 32. So we can say the horizontal velocity is equal to 32. And then do the same thing for the vertical velocity. Hopefully you've got a easier way on your calculator, but I'm going to have to do that again from scratch. So 3 divided by 4, inverse tan, and then for the vertical velocity, it's sine alpha times 40. So let's sine alpha, that's 0.6, times that by 40, that gives me 24. And then how can I write that as a vector? The vector components are going across is I, we use the letter I, and going up is, sorry, going straight up is J. So we can use that, the I and the J component to combine that, and that would become 32I plus 24J. Another way you can write that as a vector is simply to put one number on top of the other. So that would just be 32 across, 24 up, or actually it's 24 down. So because this particle, is it 24 down? Let me just check. No, it's 24 up. The velocity is going up. Sorry, getting muddled up with another question, but for this question, it's 32 across and then 24 up, and we write that as 32 on the top and 24 below that. Okay, hopefully that was a very, very easy one. Nothing too difficult about that. Let's go one step further and try to bring in the word speed. Remember, speed is different to velocity because velocity can be split into vertical and horizontal components, but the speed is the overall number you get. So if you imagine velocity can go horizontally, that's the horizontal component. Velocity vertically would go like that. Then the speed is from the beginning to the end, a bit like displacement and distance. So really, when you're trying to work out speed, you're going to be using a squared plus b squared equals c squared, as long as you know the horizontal and vertical component. So let's take a look at the next example. We've got a particle and it's projected with the velocity 3I plus 5j. Let's do a quick diagram of that. So we've got the particle and it's being projected with an initial velocity so that it's going 3 across and then 5 up. So that's the initial velocity components, horizontal and vertical. So that means the overall speed is going to be this line here. That's your vector for the initial speed. And we want to work out what that is. If this is 3 and this is 5, I'm just going to use Pythagoras. So 3 squared plus 5 squared, and then square root that. So that gives you the square root of 34. Next thing is to work out the angle. So we can use tan for that. So let's call that alpha. So we can say opposite over adjacent. Tan of alpha is equal to opposite over the adjacent. The opposite is 5, so I can put 5 at the top. And then the adjacent is your 3, so I can put 3 there. And then grab a calculator and then inverse tan that. So it's 5 divided by 3, and then inverse tan. And you get an angle of 59.03. So you can say this angle here is equal to 59.03. Okay, hopefully an easy section. You're just trying to split the velocity vector out into the horizontal and vertical components, or taking the horizontal and vertical components and trying to figure out the angle and then the magnitude. Let's call the magnitude of the velocity, which we worked out as root 34. Okay, time for you to practice that. See if you can do question 1, parts A and B. And I'll give you 5 minutes. Okay, I'll give you stop you in 2 more minutes. And just a few more seconds. Please finish the calculation you're doing and then type in the answers you've got. Okay, Bismillah, if you can type in the answers for 1A and B. Okay, the answers are looking good. So for 1A, it's horizontal is 19.15. So for part B, we'd add an I to that. And then we can round that to 19.2 just to get you in the habit of rounding to 3 significant figures. Plus, and then vertically it's 16.069, which can round to 16.1, and we'd put a J on that. And then the next one, what you had was good. So 32 for the horizontal. So I'd round that to 32.0 and add an I, plus 13.5, and then J for that. Okay, Bismillah ar-Rahman ar-Rahim. Let's go into the next section. So the next section is much more interesting because here what we're going to do is we're going to fire a ball into the air, and a bit like a gunshot, and we're going to see something quite amazing. So what will happen is that the ball will make an arc. The ball will make an arc. Let me see if I can draw that in a decent way. So expect, nope, I'm just going to have to do freehand. So what will happen is that the ball will be fired into the air and it will make an arc, a perfect kind of upside down U shape. It'll be symmetrical and then it'll hit the ground back where we fired it from. So let me just draw the ground. So if you think of that really nice, like a rainbow type path that it follows, then what you have to understand is that in the middle, exactly in the middle, is the point where it reaches the maximum height. And then back here, it reaches the ground again. And what you have to understand is that something very special in terms of mathematics happens at the maximum height. So when we're looking at the vertical height, sorry, the vertical velocity vertical velocity component starts off like this, but then gravity is pushing down. So slowly, as that ball carries on its path, the velocity component upwards gets smaller and smaller as gravity takes its effect. So in the end, not in the end, but right in the middle, when it reaches the greatest height, the vertical component of velocity is zero. So the vertical velocity is equal to zero. It's not going up anymore. So that's zero. And that's the key to these kind of questions that you're going to face where you've got the ball going in this motion. How are you going to find anything about the distance or the time it takes? The key is to know that right in the middle, the vertical velocity is equal to zero. And then what else do we know? When it reaches back to the ground, we know that the vertical distance is equal to zero again. It was zero to begin with. It was 0 meters above the ground at the beginning, and it will be 0 meters above the ground at the end. So that's how you can find out the total distance it's traveled, the time it's taken to travel by using those two facts, if you can understand them. Okay, let's begin with an example. We've just got about 6 minutes before the first break, and then I can show you this one, inshallah. So we have a particle P, and it's fired off the ground. So let's draw the ground in. And then we've got a particle on the ground. And it's fired off at a velocity initial speed of 28 meters per second. And the angle of that speed is 30 degrees. So as pictured earlier, that's gonna cause this kind of rainbow motion of the path of that projectile, and when it reaches the ground again, we're going to call that point A, and the original point is O for original. And the question is, can we work out the height, the greatest height reached? Can we work out the greatest height reached? Okay, so let's begin. Bismillah ar-Rahman ar-Rahim. The first thing is, where is that greatest height? We know it's going to be right in the middle, just here. And what's special about that greatest height? We know that the vertical velocity is equal to zero. The vertical velocity is equal to zero. So let's see what we do know vertically. We have the initial velocity is 28 at an angle, but because we're talking vertically, then the vertical component of that would be 28 sine 30 or 28 cos 30. Let's draw it out. So the vertical component would be this one. That's not next to the angle, so I'm going to use sine. So it's going to be 28 sine 30. What else do I know? I know that v is equal to 0. And what else do I know? I know the acceleration is due to gravity, so that's 9.8. But notice this time, because the ball is going up, well, acceleration from gravity would be pushing it down. So I need to change the sign there. So acceleration is going to be minus 9.8 because the ball is going up. I've taken my positive direction as up. Okay, what else do I know? That's about it. It would be nice to know what I'm trying to find out, which is the greatest height. So that's S. Okay, let's try and put that into a formula. The formulas we've used so far, I don't think they're going to work. Ut plus half at squared. That will tell us S, which is good. But do we know what u is? Yes, we do. Do we know what time is? No, we don't. So we don't know what s is. We don't know what time is. That's too many unknowns. You can't have more than one unknown. So let's try a different formula. V equals u plus at. Is that going to work? Well, it doesn't have s in it. That's what I'm trying to find out. So that's no good. So it's the third formula that's going to come in handy. We haven't used that yet. I did tell it to you at the beginning. It's v squared is equal to u squared minus 2as. Let's put in what we know. The v is equal to 0. The u is equal to 28 sine 30. The acceleration is minus 9.8. And the s is unknown. So it looks like we've got everything we need. Let's put that in. So the vertical velocity is 0. The u is 28 sine 30. That gets squared. And then I'm subtracting 2 times. Acceleration is minus 9.8. And the s is unknown. 2 minuses here, this one and this one. They can make a plus. And now I have to try to rearrange and solve that, which should be quite easy. I can take the 2 times 9.8s onto the other side as a minus. And then I can divide by something. Can you guess what I'm going to divide by? I'm going to divide by the 2 times minus 2 times 9.8, so that can come here. And then it's just a question of typing that into your calculator. So let's start with sine 30. So let's try that again. Clear the screen. So 30, I'm going to sine that, times that by 28. On your calculator, it'll be much easier to use. You can just type it in exactly as you see it, but here I have to be a bit careful. So I've got 14 for my 28 sine 30. I'm going to square that. That's 196, and then I'm going to divide by minus 2 times 9.8. So that gives me minus 10. That gives me minus 10. So what does that minus 10 mean? It means the greatest height is minus 10. That doesn't really make any sense. So let's see what went wrong there. It's probably a minus sign that shouldn't be there. And it's the formula. The formula that I had was typed incorrectly. So please change that. It's v squared equals u squared plus 2as. So that minus sign was not there. That means the distance is 10. Okay, take a 10-minute break and then we'll go on to more questions on the greatest height, greatest distance and time taken, inshallah. Bismillah ar-Rahman ar-Rahim, in the name of God, the most gracious, the most merciful. Welcome back to the projectiles lesson. Let's now we've worked out that the greatest height is 10. Let's see what else we can work out. So in a question like this, the first key fact to know is that at the greatest height, the vertical velocity is equal to 0. Doesn't mean the horizontal velocity is equal to 0, but just the vertical velocity. It means it's no longer rising. Okay, the second fact is at this point here, when it hits the ground, here we can say the distance, the vertical distance is 0. The vertical distance is 0. So now we're going to try and use that because the next question is, can we work out the time taken to get from the beginning to the end? What is the time that it will take? So let's go horizontally now. Let's go vertically now. Let me write that down vertically. What do we know? We know the vertical component of the initial velocity. We worked that out before, so it's 28 times sine 30. We know the acceleration due to gravity is minus 9.8 because this initial velocity is going up, but gravity is going down, so it's minus 9.8. The time is unknown. We don't know what the time is. The S is known, so by the time it comes back down to here, so the initial velocity is 28 sine 30, means the velocity at the beginning. The acceleration is always going to be minus 9.8. Gravity affects it at any point. And then the distance, the vertical distance at this point is equal to 0. So let's see if we can put that into a formula. S equals ut plus half at squared. Do we know everything that we need to know? The S is 0. The initial velocity we know. The time is unknown. That's fine. We can allow one unknown. Acceleration we know, and the time is the same time that was unknown. So it looks like it's good to use that formula. So we're talking vertically. Let's put in the numbers. So 0 is equal to 28 sine 30 times time plus 0.5 times minus 9.8 t squared. Here we've got a plus and then we've got a minus here as well. So that is just going to become a minus if we take that and expand that out. And then 0.5 times the 9.8, that'll be 4.9. So let's delete all of that and replace that with minus 4.9. And bring the t squared closer. And then it's a question of just rearranging, but that would be if we only had t. But here we've got t and t squared, so it's a quadratic. So here we want to rearrange and still make it equal to 0. So let's just tidy up with 28 sine 30. Let's type that into a calculator so we don't have to work with too much we don't need to. So 30 sine that and then times that by 28. That makes 14, so I can just replace that whole thing with 14. Okay, this is a quadratic, but a very easy quadratic because we can just factorize, bring out t to the front. So let's do that. Just going to need to make a bit of room. So I can factorize out for t. It's probably better to make the everything positive, but we can work with that. So 14 minus 4.9t is the factorized form. So that means that either t has to be equal to 0, which it is at the beginning, we know that. And then the other version is that 14 take away 4.9t has to be 0. So let's solve that on the side. We've got 14 take away 4.9t is equal to 0. Let's rearrange that. So that would become 4.9t is equal to 14. And then divide by the 4.9. And that's your t. So let's type that in. So 14 divided by 4.9, and that's 2.857. So the time it would take is 2.857. Let me just check that I haven't made a mistake there. Nope, that looks good. Okay, we're going to need to use that exact number, so I'm just going to keep that in the corner there. So we've worked out the greatest height, we've worked out the time taken, and now the next thing is to work out the distance from the beginning where it's fired into the air to the end where it hits back the ground. So that means we do have to look at it horizontally. So let's look at it horizontally and see what we know and what we don't know. So horizontally, we know when it hits the ground here, we know the initial velocity. The initial velocity was 28 cos 30 because it's going horizontally. So we're looking at the horizontal component that would be this way, adjacent to the angle. What else do we know? Do we know the time? Yes, we know the time because it's the same time that we've just worked out. So we can take that time and use that here. Do we know the acceleration? Acceleration is 0 because we're not assuming any air resistance or friction. We know the final velocity because horizontally nothing changes, so it still be 28 cos 30. And what we want to know is the distance. That's what we were trying to find out. So let's try a formula that we've used many times today. S equals ut plus half at squared. So the S is unknown, the U is known, it's 28 cos 30. The time is known because we worked it out before, 2.857. Acceleration is 0, so that means that is all going to just become 0. So we're left with S is equal to 28 cos 30 times by t, which is 2.857. So if you multiply that if you type that into your calculator, that'll give you what the distance is across. So on this calculator, I have to type it in a little bit differently. Cos 30 times 28 times 2.857. You should get a distance of 69.27. And that is rounded to 69. Good. Okay, so let's just go over that. There was a mistake I made earlier, so hopefully you can spot that and correct that. But the first thing we wanted to do, so first we looked at this endpoint vertically. The distance is above the ground is 0. So we used that. Vertically, we knew the initial velocity was 28 sine 30. Acceleration going down is 9.8. But the most important thing you'll have to think from your head, vertically, the distance above the ground here is 0. So we put that into the S equals ut plus half at squared formula and worked out what time was. So time worked out to be 2.857 seconds. Then we looked at it horizontally and we're saying the initial velocity is 28 cos 30 now because we're horizontal. Time, acceleration, final velocity we all know. The only thing we don't know is the distance. So we use the formula S equals ut plus half at squared. All the numbers went in and it was a very easy calculation to get 69.27. Okay, much more advanced question now. You will like this, inshallah, God willing. So this one is a bit like something being fired off a cliff, and we need to know what happens to it. So here we've got a distance of, we've got the ground at the bottom, and then we're going 42.5 meters into the air, up a pillar or a cliff, and then we're firing the projectile, the particle, at this point here. We're firing it diagonally, an unknown speed, so we're just going to call that v, and the angle we're firing at is theta, so we don't know, we do know the angle theta. It's such that tan theta is equal to 4/3. Tan theta is equal to 4/3. So when you're firing things above the ground, then what happens is the, you'll get that rainbow type path, but when it peaks and starts coming back down, then what's going to happen is that it'll just continue falling and it will go all the way down to hit the ground. A bit like the questions we did right at the beginning. So there's nothing to worry about here. You've done all the maths you need. So the question is, when it hits the ground, let's call that point A. That's a distance that we want to find out. And we also want to find out what's this velocity here. What we are told is that it takes 5 seconds for it to hit A. So let's write that down. The time is equal to 5 seconds. Okay, question number 1 is to work out V. So let's see what we know. Let's try to look at it vertically. So looking at it vertically, the initial speed vertically is V sine theta. Hopefully you're comfortable in splitting this. That would be V cos theta, and going upwards would be V sine theta. So going vertically, we've got V sine theta as the initial velocity. And imagine now we've reached the point where it's hit the ground. So the time is 5 seconds. What about the distance? Remember, distance is just a loose word, but the proper word is displacement. Displacement means from the starting position to the end position. How much has the thing moved from the start position to the end position? Overall. So the overall change is from this position down to that position. The vertical displacement is this line here. So that was our start position vertically. So we can start there and it ends here. So that distance is exactly the same as the 42.5. So we can say that the displacement is 42.5, but just be careful because we're going upwards, then we need to put a minus 42.5 because this is not going 42.5 up into the air, it's going 42.5 down into the valley below. So just be careful of that. It's minus 42.5 for the displacement when it gets to point A. Okay, what else do we know? We know, as usual, acceleration vertically is always going to be the same. That's going to be minus 9.8, and that should be enough to be able to then work this out. So let's choose a formula that's going to give us what we want. Let's go with S equals ut plus half at squared. So S equals ut plus half at squared. Let's see if this is going to give us what we want. We're trying to work out the initial, we're trying to get a number for the initial speed here, the v. So S, we know that, that's minus 42.5. The u, we've got an unknown expression for. T is known, 0.5 is fine, acceleration is known, and the t is again known. So it looks like most of it we know, we just don't know the u. So that's a brilliant formula to use. So let's put everything in. We've got minus 42.5 is equal to u, which is v sine theta. Remember that theta we actually do know. It's just we're going to have to do a little bit of inverse tanning to get it, but we do know it. Plus, and then 0.5 times the acceleration of minus 9.8, and the t squared is 5 squared, can go in. Okay, let's try and get this sine theta then. So grab your calculator. We've got tan theta is 4/3. So type in 4 divided by 3. We want to inverse tan that. So that's your theta, 53 degrees. And we just want the sine of that. So let's do sine of that. So it works out to be 0.8. So I can replace sine theta by 0.8. So that would be 0.8 times v. And then it's time for you to rearrange for v and solve it. Let me give you a minute to do that and see if you can work that out. Okay, so I'm just going to rearrange this very, very simply. So I'm going to take the minus 42.5. I'm going to take the plus and the minus here and change that into a minus. I'm going to multiply 0.5 with the 9.8 to become 4.9. 4.9 times 5 squared works out to be 122.5. So I can just take away 122.5. I can take the minus 122.5 to the other side as a plus. And then I can divide by the 0.8 to get me v. Type that into the calculator. And that gives me initial speed of 100. Okay, carrying on. The next part of the question is, oh, that doesn't look right. Something's gone wrong there. I've forgotten the t. So here I had the u, which is v sine theta. We worked out sine theta is zero point 0.8, so zero point 0.8 v, but I've forgotten the t. So the t is 5, so that needs to go in as well. So that has to be squeezed in. So let's just change that. Instead of 0 0.8, that should have been 0 0.8 times 5. That works out to be 4. So that should have been 4. Okay, then we're happy to work it out from there. Rearrange and then solve for v. And you'll get v is equal to 20. Okay, so just be careful in your substitution, especially when the theta is mixed up in the tan theta like that. Take a bit more care and that would have been perfect. Okay, next question is to work out the horizontal distance. Where does it hit the ground at A? So you have to imagine you're at this point A. So what do you know about that point? We want to know the horizontal distance. So think horizontally now. What do we know horizontally? We know that the time is equal to 5 because horizontally or vertically that doesn't matter. We know the horizontal initial velocity, 20 cos theta. And instead of making the mistake we made before, let's try and solve that now. 20 cos theta. So first we start with 4 divided by 3. Inverse tan. So your angle is 23.96. Let's now apply the cos. Okay, something's gone wrong there. Let me just start again. So 4 divided by 3. Inverse tan. So your angle is 53.13. And then we want the cos of that. So 0.6. So this can just be replaced with 20 times 0.6. Let's times that by 20, so we get 12. So the initial horizontal velocity is 12, good. We're trying to find this distance here. What else do we know? We know the acceleration is 0 horizontally, there is no acceleration. So the final velocity is going horizontally is going to be the same as the initial one, which is 12. The s is unknown, and as I said, the acceleration is 0, so it looks like we're good to use the classic formula we've been using a lot. So ut plus half at squared. Do we know s? No. Do we know what u is? It's 12. Time is 5. Acceleration is 0, so that whole thing will cancel out. So let's put that in. S is equal to 12 times 5, which is equal to 60. Okay, good. So we've got this horizontal distance, which is 60. And then the next question is, can we work out the overall distance that the particle has moved? So the overall distance is this distance here from the beginning to the end. That's that distance here. So here we can use Pythagoras. We've got a squared plus b squared will give us c squared. So 42.5 squared plus the 60 squared will be equal to c squared. So I just need to square root all of that to figure out what the distance is. So let me type that in. 42.5 squared plus 60 squared. And then square root that 73.52 is the overall distance that the particle has moved. Okay, good. Time for you to practice a little bit now. That's a lot of looking and watching, but it's time for you to see if you can apply it yourself. So let me just give you a practice question. Okay, 2 questions for you to practice, and let me give you 10 minutes. Bismillahirrahmanirrahim. That should hopefully be enough time for you to finish the question. Just finish the calculation you're currently doing, and let's take a look at some of the answers on this. Okay, for the first answer, 3 is almost right. The exact answer is 3.092 and a few more decimals, but you can round that to 3.1. Probably stick to 3 significant figures, so 3.09 seconds. If that's the number you got, well done. If you didn't, then just go and take another look at that question. So let's have a look at question 3 now and go into a bit more detail. It's the same technique as before, nothing different, exactly the same technique. So let's imagine we've got a horizontal ground, and then we're firing the stone from above the horizontal ground. So the stone is being fired from about here. So that means there's a distance that is between the stone and the horizontal ground. So it's being fired off a cliff or something like that. Now, the the speed that it's being fired off at is 32. How do we draw that 32? Do we draw that going up this way, going up that way? Actually, it says it's below the horizontal. It says below the horizontal here. So below the horizontal, 10 degrees below the horizontal means it's being fired off downwards. So it's fired off at a speed of 32 meters per second, and the angle with the horizontal is 10 degrees. So this angle here is 10 degrees. So when you're trying to work out the vertical and horizontal components, that's where the angle is. Okay, the time it takes is 2.5, which is going to help us a lot. Find the height in question 1, the height above the ground. So they want to know the height between the ground and where it's thrown off. So we need to be looking vertically. We need to be thinking vertically. What do we know? We know time is equal to 2.5 to reach the ground. So by the time that it hits the ground, probably about somewhere here, it's taken 2.5 seconds. What was the initial velocity when vertically? The initial velocity was 32 meters per second, but we want the vertical component, so that's this one. That's not next to the angle, so that's going to have to be, let me just draw that in for you so you're clear. We want the vertical component of the 32, so that's this bit here. So that's going to be 32 sine of 10. 32 times sine of 10 degrees is the initial velocity going down. What else do we know? We know that acceleration is going to affect things vertically. 9.8. Notice this time it's 9.8 as a positive. Why? Because the speed of 32 is going downwards. So the gravity is acting downwards as well. So both of them should be in the same, with the same sign, both positive. So 9.8. Okay, what else do we know? Or what are we trying to find out? We're trying to find out the height. So we can say that S is what we're trying to find out. That's unknown. So think about your formulas. What's going to work here? Maybe S equals ut plus half at squared. Let's try that first. Okay, let's just go through each bit to see whether we know it or not. The S is definitely we don't know it, but that's okay. We can have one unknown. The U, we know it. It's 32 sine 10. The time, we know it. The acceleration, we know it. The time, again, we know it. So that should be quite easy to type into your calculator if you substitute correctly. So u is 32 sine 10 times the time, which is 2.5, plus 0.5 times acceleration of 9.8 times the time of 2.5, but this time it gets squared at the end. Okay, I don't have enough space to put that in. Okay, so there's what you need to type into the calculator. Let's type that in. So 32 times sine of 10 times 2.5 plus 0.5 times 9.8 times 2.5. So you should end up with a distance of 26.141. I'm just going to check that on a proper scientific calculator that I've got next to me. You can check it as well. Ah, the squared. I haven't got the squared on, so that final 0.59 times 9.8, that should be, it's s equals ut plus half at squared. That should be a 2.5 squared. So let me try that again. To get a squared on this, I'm just going to put a little arrow to show the 2.5 gets squared. Okay, try typing that in now. Times the 2.5 plus 0.5 times 9.8 times, and this is 2.5 squared. Okay, so you should end up with a final answer of 44.516. And that's part one done. Okay, let's just go through that to make sure you didn't miss anything. The first thing is to get the diagram with the 32 pointing downwards is 10 degrees below the horizontal. So there's your 10-degree angle. And then the next thing is to think about what you know. If you're trying to get the height above the ground, you've got to be thinking vertically. So vertically, you know the time is 2.5. You know the initial velocity is 32 sine 10. You know the acceleration. Notice we had it the positive this time because it's being fired downwards. And then put it into the formula, put everything into the formula and solve to get the vertical distance. Good. So then the next bit, let's see if we can do that as well. So here we've got to work out the distance from the point on the ground vertically. Okay, that's a lot of words, but all they're asking you to work out here is that eventually this particle is it's gonna get fired down towards the ground, and then it's just gonna hit the ground here. And all they're asking you to do is work out this horizontal distance here. It's from below where it gets fired to where it hits the ground. So we've got to be thinking horizontally now. Got to be thinking at the point that it hits the ground, what do we know? At the point it hits the ground going horizontally, then we know the time is equal to 2.5. What was the initial velocity? Back to the beginning, the initial velocity was 32 sine 10 going down, so it'd be 32 cos 10 going across horizontally. acceleration is 0, no acceleration going across. Uh, we know that s is what we want to try and find. So, and acceleration is 0. So let's put that into the formula. Formula is the common one we've used so far, s equals ut plus half at squared. Make sure you got the squared in. Okay, we don't know what s is, that's fine. We do know what u is, we know what t is. A is 0, so that means that's going to cancel. All we're left to do is do s equals 32 cos 10 times by 2.5. That's your 32 cos 10 times that by 2.5. And you work out that the horizontal distance is 78.7846. Good. Okay, hope you enjoyed projectiles and are feeling confident. You know how to use the s equals ut plus half at squared formulas and the other ones, and know how to split the velocity vertically and horizontally. Know that when you're working on a question that you feel confident, you can look at you can look at things horizontally and you can look at things vertically, and you know what acceleration to use vertically, and you should be fine, inshallah. Take care. Assalamu alaikum wa rahmatullahi wa barakatuh. Next lesson is in 2 weeks' time.